Bismillahirrahmanirrahim. Assalamu alaikum. In this video, we are given with the task from Digital Logic Design by our respected teacher Dr. Riaz Hassan, Assistant Professor, Department of Electrical and Computer Engineering at Comsat University, Islamabad. First of all, I'm going to introduce myself. My name is Ibrahim Ahmad and I'm currently studying in one of the top university of Pakistan. I'm doing my bachelor from Comsat University, Islamabad. Let's start presentation. During this presentation we have the following content. Let's have a look on the task given by our teacher. In this task you have to design a combinational circuit on proteus that display 3 digits of your registration number on a 7-segment display. The circuit should display first the hundreds, second the tens, and third the ones digits of your registration number when the input are 0001, 0010, 0011 respectively. When the input are these, the output on 7-segment display are first the hundreds, second the tens, and third the ones digit of the tens complement of your registration number respectively. Likewise, first the hundreds, second the tens, and third the ones digits of the nines complement of your registration number are displayed as the input combination are these respectively. For all other 4-bit valid BCD code input combination only the middle segment is on, whereas for all invalid BCD codes as input you can apply the don't care condition. Here overview on this task we got 3 main highlighting points: first one, second, and third. Further explanation of the task. In this task we need registration number. In my case my roll number is 083. So the first condition which are given in this task is when we have input 0001, it should show the 100 digits of our registration number, which is 0. When the input is 0010, it should show the 10 digits of our registration number, which is 8. When the input is 0011, it should show the ones digit of our registration number, which is 3. And condition 2, it's given when we have input these inputs, it should show the 10th complement of my registration number, which is 917. Similarly, with condition number 3, when we have these input, we should show it should show 9th complement of our registration number. And all invalid BCD codes are as input, you can apply the don't care condition and it will reduce our circuit diagram. So on the right side I share a screenshot how to find the 9th complement and 10th complement of my registration number. Let's move to the next slide. Here is the whole overview of the task. When we have input 0001, it should show the 100 digits of our registration number, which is 0. When the input is 0010, it should show the 10 digits of our registration number, which is 8. So on the right side here we will give input A, B, C, D, and it will give us output A, B, C, D, E, F, G, and then we will use A, B, C, D, E, F, G as an input of for 7-segment display. So let's see how 7-segment display work. Here is the simple diagram of 7-segment. We have input A, B, C, D, E, F, G. We have 7 input and this is decimal point and we don't need it here in this task. You can use it but we don't need it here. Okay, let's see how we can show a different number on these 7-segment. Here is the chart. If you wanna see 0 on this 7-segment display, we're gonna keep all high except G. We're gonna turn on A, B, C, D, E, F high and the rest of G should be low, and then we will be able to see 0 on this 7-segment display. I have an animation file for this. It will explain it furthermore simpler. Here Let's see how we can see 1 on this 7 segment display. If we keep BC high and all of the rest of them low, so we will be able to see 1. Like here, we keep BC high and the rest of them A, D, E, F, G low, so we will be able to see 1. And here similarly, how we can see 2 on 7 segment, when we keep C and F low and the rest of them high, so we will be able to see 2 on this 7 segment. Similarly with 3 and 4. Now we have to make a truth table which take BCD as an input and give us a 7 segment display as an output. So here we have a truth table as it given in our task that when we have input 0 0 0 1, it should display 0 on 7 segment display. So now we will write the input for 7 segment display to show 0. So in an earlier slide we see that when we need to show 0 on 7 segment, we have to keep all of them high except of G. So here in this truth table we need to see a 0 on this input, so I keep all A, B, C, D high and G is 0. Now this will give us 0 on 7 segment display. Similarly, when we have input 0 0 1 0, it should display 8 on 7 segment display light. To show 8 on 7 segment display light, let's go back to the slide. 8, we need to turn on all the lights and then we will be able to see 8. So I keep all of them are high, so then we will be able to see 8 on 7 segment display. Similarly with this 0 0 1 1 input, we need to show the ones digit of our registration number, which is 3. So to show 3 on 7 segment display, we need let's go back and see, we need to show 3, these 3. We need to keep E and F low and rest of them high. So I did same thing with this. I keep E and F low, the rest of them are high. Similarly we do at the 10th complement, and similarly we done to show the 9th complement on 7 segment display. So here we got the whole truth table, and now we gonna make it simple. We need to reduce this truth table. We need to get a reduced Boolean expression for A, B, C, D, E, F and G through Carnot map, so that we can draw on Proteus. We can simulate on Proteus as well as on xilinx. To get the simplified Boolean expression for A, we need to use Carnot map on A. So let's see Carnot map for A. Here we have 0 m0 is don't care condition, so we put X or don't care condition, and then we have 1 2 3 4 high, so 1 2 3 4 is high and 5 is low, so 5 is low, and 7 9 is high, and 7 and 9 is high, and 8 is again low, and rest of them invalid BCD code. We can use it as a don't care condition. So here we got the simplified Boolean expression for A: B complement D plus B D complement plus C through sum or product. Similarly, we will find the Carnot map for B, C, D, E, F and G. So here I done it, and here for E, F and G. This Boolean expression for A, B, C, D, E, F and G through Carnot map. Now we can easily make a circuit diagram through this. Let's see how we can make a circuit diagram. We have the circuit diagram for A. So we have 4 input A, B, C, D. and we attach not get with a with it to make it a complement, b complement, c complement, and d complement. See, there is 2 and get and a simplified Boolean expression, so we will use 2 and get. 1 is here and 1 is here, so we're gonna attach the one end of this and get with b complement and the other end with d, and the another and get we will attach the one end with b and the another end with d complement. Now we have or get between these three terms. Now we will attach these three terms output with input for the OR get, b complement d, bd complement, and plus c. It will give us output a. Similarly, we done with b, c, d, e, f, and g. Now let's have a look on whole picture here. So I will explain it on circuit diagram. Here we can't see more clearly. I can't zoom it on slide. Let's go for circuit diagram. So here we implement all the gates as we see in the last slide. I will explain the A. Let's zoom it in. This is our whole circuit diagram. Okay. As we simplified the Boolean expression for A on Carnot map, we got A complement D complement plus B complement D complement plus C. So here we have two AND gate. We attach one endpoint on this AND gate with B complement and the other end with D. So we will get expression B complement D from this AND gate, and the other AND gate we attach the one endpoint of this AND gate with A complement here and the other end with D complement. So we will get A complement D complement terms from this AND gate, and now we have OR gate between these three terms. So we will attach this output as an input for the OR gate, and C and A complement D complement as an input for this OR gate, and it will give us A. Similarly, I make a circuit diagram for B as A complement plus D complement. We use only one OR gate, and we attach the one end of this OR gate with A complement and the other end with D complement. Similarly, we have C is equal to 1, so I just take 1 as an input for C, and similarly I make circuit diagram for D and E, F, and G. Now we will attach the output of A, B, C, D, E, F, G with 7 segment display. Now let's see how we gonna attach this output with this 7 segment display. We have output A, B, C, D, E, F, G. Let's go to slides. As on slide number 3 we explain, when we have A, B, C, D, E, F, G outputs, now we gonna use it as an input for 7 segment display light. So we gonna attach A with the top light, B with the side one, top side one, C with the down side one, D with the down one, and similarly E here, F here, and G here. So now let's attach the output A, B, C, D with the 7 segment display. So here we have to see which wire should connect with which light. Here is the explanation on this website. This website is more clear than the Proteus, so I use this website. I don't have Proteus. And here is T is our A, so we're gonna attach A with this T and B with TR. Let me show you. Here we have A output. We're gonna use as an input for 7 segment display light, and we attach it here with T, which is our A, and here is a B. We're gonna attach it to the TR, which is our B, to the side light. And similarly I connect C, D, E, F, and G. I connect all wire to 7 segment display light according to this table. So now let's check it show us our number or registration number according to a task or not. So let me have this condition table over here. I wrote this condition on a sticky note. So the first condition, on this input it should show us 0, and the second this input it should show us the 10th digit of our registration number, which is 8, and with this input it should show us 3, the one digit of our registration number. Let's give input 0 0 0 1, so it shows 0, the 100 digits of our registration number. Now let's give 0 0 1 0, it should show us the 8, 0 0 1 0, so it show us 8, the 10 digit of our registration number. Now let's give the input 0 0 1 1, it should show us 3, the 1 digits of our registration number. Similarly with let's confirm the condition number 2. We have input 0 1 0 0, it should show us the 100 digits of our registration number, 10 complement of our registration number, which is 9. Similarly with the other input 0 0 0 1 0 1, it should show us the 1, the 10 digit, and with 0 1 1 0, it should show us the 1 digit of our 10 complement registration number. Now let's confirm the condition number 3. 0 1 1 1, it should show us the 9, which is 100 digits of our 9 complement registration number. Now we should give the inputs 1 0 0 0, it gave us the 10th digit of our registration number. And now give the input 1 0 0 1, it gave us the 1st digits of our 9th complement registration number. So here we confirm the circuit diagram, it's working properly, and now we have to do work on xilinx. Let's see how to do it on xilinx. To simulate on xilinx, first we need to open xilinx, and then we'll create a new project, and then we will add a new source text module. Then we will write the following code. We will take BCD as input, and we need to see a 7 segment as an output. We will apply always loop on BCD, and then as we know that for 0 0 0 1 we need to see the 100 digits of our registration number, which is 0. So here 1 1 1 1 1 1 0, it's mean 0 on 7 segment. We write this from the truth table. Here we constructed 1 1 1 1 1 1 and 0. We're gonna write all these 9 7 segment input here for each input. On this 0010 we need to see the 10 digits of our registration number, which is 8, and here is 111, all are high, it means 8. And then we will create a test bench for it. So here is the test bench. We register BCD as input, where 7 segment is an output, and then we mention it, and then we give them time to simulate it as number wise, and then when we simulate it, we will see something like this. Let me explain you the graph here. So here let me explain you the graph we got from xilinx simulation. Here we have BCD as input, and it will give us output this 7 segment display. Okay, so on 0001 we need to display the 100 digits of our registration number, which is 0. So 1111 0 is responsible to show 0 on 7 segment display. Similarly, for 0010 we need to show the 10 digits of our registration number, which is 8, and 11111, which is responsible to show 8 on 7 segment display light. And you can check all of them with your truth table. With these I'm gonna end my presentation, so I'm gonna conclude what we learned from this presentation. So let's go for the first slide. From this presentation we learn how to take 9's complement, 10's complement, and then we learn how 7 segment display work and how we gonna make the truth table for that, and then we see how to make a knob map and how to get the simplified form, simplified Boolean expression, and then we saw how to make a circuit diagram from simplified Boolean expression, and then we see how to connect all these to the 7 segment display light, and then we see how to simulate the same task on xilinx and make its test bench and show its results as a graph. So there's a lot of things we learned from this task. This was a useful task given by our teacher, and if you for all YouTubers viewers, if you have anything, any problems or any issue, if I did some mistake, you can correct me and comment, and I will share the whole document, the presentation file, the PDF file, and code and link to the circuit diagram, to this diagram. I will share all these links in description. Hope you guys like it, and I hope it will help you. Allah Hafiz.